Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it's live, and a link in the info box below this video once it is rendered. Most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected. And if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show, as this increases the live audience, of course, and that in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you are new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Ruhif and Sleeping Warrior. How are you both doing, gentlemen?
All is good, all is good.
Thank you, Nathan.
Excellent. Good to have you both.
So, what shape of Earth do we live on, Ruhif?
We live on a ball, Anthony.
How do you know
You
that?
should know that, right? We can get into what I was going to bring up last night, right?
Just by the way, Nathan, will you let us know when you've publicly put the link out?
I'll put it out now, as far as I know.
Oh, right,
I'll
okay.
double check that, but I'm pretty sure it's out.
So a very, very simple experiment with the theodolite. If you were to go to St. Bees Head and look, so the top of the hill, so the 115 feet hill, and you were to level off your theodolite, would Morgold Lighthouse be above the crosshairs or below the crosshairs?
It would be on the crosshairs because the scale would be that small you wouldn't be able to tell whether it's above the line or below the line. And
Well, the
theodolite wouldn't
height,
have the zoom capability to be able to even see it, I don't think.
the height of the St. Bees was 115 feet, and the height of the lighthouse, the focal height, was 230. You'd be looking up, right?
Yeah. In theory, you'd be looking up. In practice, I don't think you'd be able to see it to be able to ascertain where it actually is, because theodolites don't have like 83 times optical zooms on them.
You can't hook up a P900 to it?
I don't know.
That's
possibly.
a good question. We were having this
by the way,
conversation yesterday, Ruhif. I don't know if that's possible. I mean, the thing I suggested was maybe just literally pointing a P900 through a theodolite, but other than getting it in focus, I don't think you'd get any more zoom out of it. I don't know if I'm right. I've never tried.
Can you present me, please? Look what I have. Ooh.
Yes. Welcome to the club.
Yeah. Woohoo.
So how would you convert that into a theodolite, though?
I don't know.
Me neither.
I've never used one. Like, I know theoretically how to use one, but I mean, I've never actually used one.
I honestly don't know how it could be done. You'd have to speak to somebody like Jesse Kalowski or someone like that who uses them, uses theodolites. There may be a way of connecting it, and that would be cool if you could. I don't know whether you could or not.
It would be a simple experiment, right? Because you got, what, 500 and something feet of drop.
But then that takes us into the question of optics, because without any atmosphere, it would be slightly above it. But we know that when we look through the atmosphere, we know that things are not necessarily in the place that they actually are. There is an apparent horizon.
Sorry, come on. Aren't you going to quote Nathan there?
With regard to the line of the horizon, I'm going to quote what we did.
No, we see it because it's there. Is Morgold Lighthouse there, or is it a mirage?
Yeah, Morgold Lighthouse is there. But we
there.
also know that the horizon isn't necessarily the actual horizon. It can be an apparent horizon over the optical horizon that the apparent horizon.
I'm not concerned at all about the horizon. I'm concerned about leveling a theodolite, pointing it straight out towards a lighthouse. Is the lighthouse above or below?
I think the base would be exactly in line because they're about the same height as the hill, are they not? So the base of the lighthouse is approximately the same height as your observation position. So based on us being on a flat plane, I would say that your level.
There's 100.
I don't know.
There'd be 100 feet difference, so we'd have to do a bit of angular
30 miles.
Size.
That amount of
sorry,
the
base of the lighthouse. Where does that sit? I can't remember off the top of my head how high the base is.
110, I think it is.
I worked out on the day that you did the observation, it was 159 feet because it was low tide. The focal height 65 and the 65 meters, sorry, and the tower height itself is 23 from memory. So 46 meters, 160 feet roughly.
So you're about 60 feet. So the base of the lighthouse is approximately, based on us being on a flat plane, about 60 feet above your observation position. So yeah, you'd be looking one tenth of 1 degree up, something like that.
Yeah. Well, what's the resolution on a theodolite?
I don't know. Honestly, I don't know.
I don't think you'd be able to measure it because I think it'd be too small in the reticle. I think the crosshairs would cover it, and I think that if you could see it and get it in screen, it would be so minuscule that you would be. It's like you're measuring the difference in between like thicknesses of human hairs. I think it's negligible, literally negligible. Not standard refraction negligible at 15%. I mean negligible in the ordinary meaning of the word.
Would it be negligible if the Earth was a ball?
I don't think you'd be able to distinguish between the two. To be honest,
if
you're saying you can't. What's the drop between St. Bees and Mogod Lighthouse?
Correct, I'd agree with you. If the Earth was a ball, there would absolutely be a drop between you and that lighthouse. I think it's something like 600 feet. It's below your feet, correct?
Yeah, so we can clearly distinguish, a difference of 600 feet, right?
Yeah.
Through a theodolite.
Hold on. So
Definitely.
it's obscured and
right.
dropped 600 feet below your feet with a wall of water in the way. So we wouldn't see it at
Well,
all.
no, we can see it. The drop is not.
I know we can see it, but I'm saying on a ball, it's obscured by the horizon, and there's a 600-foot drop.
Now the problem then.
Yeah, so on a ball, it would be much below the.
It would be gone.
Right?
It wouldn't be seen. It would be gone.
Let's test it.
Not test it. It would be. It's 600 feet below your feet, and there's a 170-foot wall blocking your view.
25 quid. What's that? $50 here.
Why aren't you acknowledging what I've just said? On a ball, it ain't there. It's not there at all. It's gone. 600 feet below your feet, and there's a 170-foot wall in your way.
No, I get, 31 miles at 115 feet elevation. I get a refracted hidden of 161 feet.
Oh, refracted hidden. Sorry. Oh, we're back straight into this conversation. Excellent. Can you prove the R in 76R?
I don't need to for this experiment.
Oh, so you're presuming the Earth is a sphere in your calculation. Rather than proving it's a sphere, you're just going to assume R is correct and just assume you know the radius, correct?
No, it's...
Yeah, that's what you've just done. You've just said using standard refraction. Well, standard refraction is 76R. You assume you know the radius. Before, you're trying to prove that there's a radius, right? But yet you're inserting this mathematical formula that automatically and already assumes the radius. That's called begging the question.
Sorry. Can I say something? I think it was Nick in the chat said, what was the... yeah, Nick, there you go. 7 minutes in, Ruhip is winning at the moment. Thank you, Nick. I said 5 minutes offered, and what are we? 7 or 8 minutes in. Anyway.
Sorry, just to clarify this for the audience. So Ruhip has just asked us what we would expect to see on a flat plane of the lighthouse. And I've explained, yeah, we'd pretty much see the lighthouse. Yeah, that's how it looks on a flat plane. On a ball, however, it'd be gone. It would not be seen. It would not be there. You would not be able to see it. Now, Ruhip has just gone to a presumptive argument that he already knows the curve. He's got 76R to bring it back, which means he's automatically decided it is a ball. He's not proving it with this lighthouse. He's just assuming it with this calculation, 76R. So I'll ask a second time, Ruhip, while you've just declared that you're winning this conversation, there's a calculation you've just inserted that's 76R. So what's the R?
No, sorry, what I was talking about with Nick.
What is the R? No, I'm talking to you. Don't converse with the chat, Ruhip. I'm asking you a question, Ruhip. Don't converse with the chat. Do you have proof of R?
It's irrelevant for this.
So, no, it's not irrelevant. What it's doing is begging the question. You're automatically assuming the Earth is a sphere rather than actually proving it's a sphere. So, I'll say it again. On your globe model, without automatically just assuming you already know the radius, this lighthouse isn't there. It's gone.
It would be below the crosshairs. Either invisible or not.
No. No, gone.
What?
Gone. Not visible. Gone.
How could you explain it being below the crosshairs but visible?
No, Sorry. It's not visible.
I'll say it one more time. 600 plus feet below your feet, 170-foot wall in the way. It ain't there. It's gone. It's not there. You can't see it. It's gone.
170 foot. Didn't we just establish that the height of the base is like 160 foot?
The whole thing is 600 plus feet below your feet, and there's a wall in the way on a globe. Now, you can try and assume that light bends back around the curve, bringing it coincidentally to look just like it would on a flat plane. I'm just not going to let you assume that without any proof that that actually is occurring. You have no evidence of that whatsoever. So to automatically assume this calculation is completely and utterly fallacious, Ruhif. Yeah, you're not proving that it's a ball. You're just assuming it in this calculation, right?
The 600-foot drop is reduced. Is
reduced by an assumptive argument that you have refraction bending around a ball. That's what you're doing.
It is reduced by looking down very slightly.
No, not very slightly. It's gone. On your bullshit ball,
number
it's gone.
Refracted hidden.
Gone. Gone. Not visible. You know when you say brought back, that's assuming light bends around the ball that you are assuming. You understand that?
Yep.
Right, so it's a completely assumptive argument and proves absolutely nothing.
Are you denying refraction again, Nathan?
No. I've had this conversation on multiple occasions. We do not deny refraction. What you are doing is assuming it bends around a ball with no evidence. Zero.
Let me rephrase it in a different way so that maybe you'll see the point at least. If you're going to calculate for standard refraction based on a radius, you're effectively making the assertion that there is a radial adjustment to be made. Now, he who asserts must prove you're making an adjustment based on a radius. Prove that radius, please.
So I'll ask again. What's
you're talking about
the proof of R in 7.6R? That's what you've inserted. Where's your proof?
Wait, right? Sorry, that cut out a bit. Do you realize that the 7/6R is not... it's a reflection of the refractive index over the assumed radius of the Earth. So
right, so we've got an assumed radius. You're here to prove radius, not assume it. Do you get it?
Hang on. I take issue with that description. It isn't that description at all. 7 divided by 6 based on a radius is an arc.
Yeah, of course.
So we've got an arc already. Wow, isn't that handy if you're trying to prove a curve? If you've already got one in your maths. Wow, that's handy. Very handy. Listen, yeah, I don't want you to just assume there's one, Ruhif. Don't please assume. Don't just assume there's a curve, my friend. That's not what we're here for. We're not here to assume anything. All right, Arev, how you doing? Is that really you?
Hello.
Oh, good to have you. Good to have you. Yeah, so yeah, please don't assume there's a curve, Ruhif. Don't assume it.
No, if you were to bring the surface of the Earth back to being a flat plane...
Hey, Dawn, how you doing?
And you apply the same...
Hi, hello.
Good to have you.
All right. Yeah, if you bring the surface back to being flat and apply the same refractive index that you did, so that, the 1.000250, whatever, you'll still get a curve. It'll just be over a flat plane.
But the 7.6 is just saying that you're dealing with a fatter circle. Like 6.6 would be 1. It basically means you're dealing with the same size circle. 7.6 means you're dealing with a slightly fatter circle by 1/6, because 7.6 is a fraction of 7/6. 6 pieces make a whole, so there's 1/6 left over. You're dealing with a circle now that's 1 and 1/6, radius or whatever larger. It's an assumption. And then on top of that, if these objects are looming or refracting into our view or whatever with this refraction, why don't you see objects that are behind the building? Like, say a building is refracted into your view from like a couple miles away. If you zoom in with a camera, would you magically see an object behind it that loomed over that building into your view all of a sudden with this looming? I mean, how would light even work with this? Most of the time we work with linear light that propagates in straight lines with no curving and that doesn't do all these weird behaviors.
Did you just ask if we zoom in, will it then show us something behind? Like, will something loom purely because we've zoomed in?
No. Can I rephrase that, Arev? So if you're standing at the bottom of a hill and you're looking up at that hill, do you ever see your mate's house looming on the top of that hill?
My what house, sorry?
So you're standing at the bottom of a hill, and on the other side of that hill, you've got a mate's house. It's at the bottom of the hill, and you've got a hill between you and it. Have you ever, in any instance, seen your mate's house projected up to be looming on the top of the hill?
You're asking whether light can bend around things?
No, I'm asking,
Pretty
have you
much,
got an
yeah.
example other than what we present that is absolutely flat earth in relation, in measurement, in every single instance, just happens to be negated by this assumption that you're on a curve with light bending around said curve? I'm asking, are there any other real world examples where you've stood looking at the top of a hill, like we're looking at in the instance of the Isle of Man? You're looking at the top of a hill. There's a hill in the way. Well, I'm asking, give me a different example where there's a hill between you and a target object, and the target object looms to the top of the hill so you can see it.
We can do that. Let's look at the
Excellent.
Beyond Horizons world record.
No, not Behind Horizons.
No,
It's
you
not
can't
just
prove
beyond
it.
the horizon
Why
this
not?
would happen.
Sorry,
Surely
is
there'd
this
be
a thought
other
experiment
instances.
now, or are you talking about?
So you're talking about now beyond an assumed horizon, right? A horizon that's closer to us, correct, Ruhif? Are you now going to assume we're on a ball again?
Sorry, cut out again.
Is the horizon you are referencing a horizon that is closer to us than the target in the distance?
Yeah.
So you are assuming again that we are on a ball automatically before actually proving it. So you assume the horizon is closer to us. So you're assuming we're on a ball again. Why are you doing this, Ruhif? How many times have I told you?
Why am
Don't
I doing this?
assume.
Because you won't do the experiment.
Don't assume the horizon's closer to us. That is only necessitated by your presumption we're on a bloody ball. Don't assume we're on a ball, Ruhif. Please don't.
We have to
Again,
assume that. That's our position in the debate, Nathan.
No, you
Uh,
can't.
right.
Maybe we'll
you
get
could
better
take-
results if we.
So I'll say it again, just for Dawn the dickhead, who doesn't seem to understand. If you're going to declare that the horizon is closer to us, first you must prove it. Don't just assume it.
Flat earthers would assume that we were on a ball, say, if we saw a hump of land blocking our view in the distance. But when you zoom in on that hump,
That's what we
the
see
hump
in
disappears.
reality.
No, we've just gone through this, Dawn. On a ball, lighthouse not there. Remember? I published this a couple of days ago with you specifically, Dawn. Lighthouse not there. Remember?
I can remember some pixels of actually seeing the lighthouse.
Yeah, that's right, Dawn. We do see the lighthouse. Well, we shouldn't
It
if we're on a presumptive
loomed up,
ball,
right?
should we? The problem is that when we point out that we shouldn't see it on a presumptive ball, you say, no, we also assume light bends around the ball that we assume. So, yeah, this ain't going to happen
Question,
no more,
actually,
Dawn.
Nathan.
This ain't happening. No assumptions
Question.
no assumptions that curvature's closer to us in the form of a horizon. That would assume we're on a ball.
So you're allowed to assume it's flat, but we're not allowed to assume
we
it's a
show
ball.
straight line measurements being taken and simple trig calculations being done. We don't assume 76R. We don't assume
Let's
R.
do that.
We don't assume anything. We just take a measurement, just like a surveyor would do.
Let's do some straight line trig. Take your theodolite to the hill at St. Bees.
See, it's back
Level it,
into. Let's go and do a
and
new
tell me whether the,
experiment.
lighthouse
So no
is above or below
scientific
it.
proof whatsoever. No proving R. I've just asked you to prove R. Now you're telling me to go to the beach to prove R, like
This will
exactly
show you-
like Rumpus
This will
did.
show that the lighthouse is below your horizontal.
Right.
It
It
drops
shouldn't be
away.
there at all, Ruhif.
Say again.
If you think you're on a ball, it shouldn't be there at all.
No, sorry, that was a question I had a minute ago. Can you accept on our model that if the Earth is a ball, that light will refract in a curve?
I don't assume
Do
the
you
Earth's a
accept that?
ball.
No.
No, I don't assume that.
You don't.
Curve.
I don't assume
Well,
we're on a ball.
that's an
and I
assumption
don't
that
assume
has
light
to
refracts
be
around
for,
it.
for,
You
for
assume
things
those
to be
things.
seen on the globe. That has to be part of the model. Otherwise, there would be things that you're not seeing, like this lighthouse. It would curve away, and people would be asking, "Well, we shouldn't even be able to see the lighthouse, but we are." So the theory has like an assumption in there to compensate for that.
Yeah, but you understand the fundamental reason for refraction, right? And why it curves.
Yeah, to
Yeah.
make
Because we're assumed to be on a ball, which may be an error.
No. We're talking about the difference in density and temperature. As
Well, look
light
at.
passes.
Let me see if I can share my screen real quick. Hold on, and show you guys what I'm talking
So
about.
are these assumed temperature
Screen share.
differences and temperature variables at the photograph position, Ruhif? Are you assuming these conditions, are you? Or do you have proof of them?
Could I see the photo again?
No, I'm speaking-
I'm lost if this is
speaking
a thought
theoretically.
experiment
Hold
or
on,
an actual
Dawn, let's just
photo.
get an answer from Ruhif. Are you assuming
I wanna
these
play the, Beyond
conditions,
Horizon
or do you
photo,
have
yeah.
proof of them?
Sorry, you cut out when I speak, sorry.
But it's okay. do you have proof of these conditions that you've just talked about?
I'm sure I could get metadata.
So is that
I mean,
a no?
the
You
standard-
don't have proof of these conditions? There's still an assumption?
For which observation?
Sorry, we're only
We're
talking
not even-
about
we're not
this
even talking about an
lighthouse.
observation yet,
Why are you
so-
asking me which observation? We're talking about this lighthouse, aren't we? You know what observation we're talking about.
Which
Oh, okay.
lighthouse?
Then get your theodolite.
Morgul Lighthouse.
Right, Morgord Lighthouse. Thank you, Dawn. At least Dawn's keeping up, Ruhith. So, do you have any evidence of these conditions you just described, or do you just assume them?
Oh, completely assume them, but it doesn't matter.
Right, so how many times have I got to say it to you? Don't assume anything.
Will the lighthouse be above or below the crosshairs?
Yeah.
That will determine whether it drops away or not.
Right, if
Right,
we
so
did
how
it
do we
retrospectively
assume no
now,
refraction? Let's
in
assume
the
no
aftermath,
refraction.
if we did it
Well,
now.
if I may, I'd like to screen share y'all. Can
Yeah,
y'all
go
see
ahead,
my
sorry.
screen? No problem.
Yes.
So,
You just
all
shared
right.
the link. Oh, that's all right. Go on. Yeah.
So, all right. So you're basically saying light is propagated by refraction on a curved Earth like this, right? Is that what you're saying?
Draw another line. Draw. Yeah. Well. Yeah.
All right.
Do
so
you
if light's
understand the
bending like
basic
this,
science of refraction?
yeah, but if light's bending like this, that means that on the outer part here, it's tight. It's more spaced out than the inner part here. So why don't we see something like a rainbow effect with the outer portion of light bending more on this part than on this part? Wouldn't that happen if light was bending?
Rainbow.
This diagram, all right, that's amazing.
I mean, why don't we see any prisming of light if light refracts in this way? Most of the time, I've heard of light refracting in this way, like ping, 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 like in linear
that really
reflections.
represents how light works.
Yeah.
Ping, ping, ping.
I'm not seeing.
So, okay, if that's the case, say you have a building here, and you're over here, you're the observer, and it's on this curve.
This is-
Sorry for my
This is
terrible
fantastic.
math. And
Didn't
it's
I get?
refracting to you.
What's the word?
You're
Oh,
saying that it
wow.
would refract like what? Like this?
Hold on, I can't hear what Arif's saying.
Sorry.
You're saying that it would refract like that off of the atmosphere or whatever, off of this, these clouds or whatever, right?
No, that's not what they're saying.
Not the
No,
clouds.
not at all.
In a curve, in that it's going through. I guess what you describe as infinite temperature changes and
I love
density
it.
changes.
So that's why I asked if you had any proof of these infinite layers of refraction that it goes through, Ruhith. So assumptively, it's not just going through
would
one
you like
angle
me to
change,
get-
Arif. So assumptively, there's not just one angle change. It's not just one effect of Snell's law taking place. It's multiple effects of Snell's law. Loads and loads and loads and loads of layers of refraction, infinite numbers that they just assume. They don't have any proof. They just assume that that's what's happening. It's a total assumption. It is quite literally meaningless because assumptions about what refraction is occurring don't mean anything to anybody.
But the thing is, we need to establish how light is working. If light is curving the way that you say it is, where's the rainbow effect? If there is none, then you're
I'm
saying
not
a
convinced there
contradiction.
should be one.
You're saying in one place that it works by straight line propagation and reflection, and in another place you're saying that it curves. That's a contradiction.
Sorry, where am I saying it's straight line propagation?
Well, most people would say that light propagates in straight lines. Am I correct?
Yes,
Well,
hence
your
what's going
artwork, all right, that's already being shared now.
Okay, let me hold on. Most people are saying that light propagates in a straight line like this, correct?
You're not
What if
sure.
it goes through an atmosphere? It's going to curve.
So you're saying it curves through
How
an
do you know it's
atmosphere.
going to curve if it goes through an atmosphere? What evidence have you got to show that that happens?
Well,
Yeah,
that's why I'm
basically
asking.
prove how light would
Do you guys
propagate
have a
this way.
fundamental understanding of why it curves?
Sorry, he's just asked you a question. He's just said specifically, do you have any evidence of precisely what you are claiming? Sorry, bear with me a second while I deal with this sniper. Hopefully we've not lost the entire hangout. We shall see. Is everyone still here?
Yes.
Okay, sorry.
Hello.
I'm not sure he was a sniper. Completely forgot what the question was. I was asking whether you guys have a fundamental understanding of why light refracts through an atmosphere.
Yeah, we understand that you apply something called Snell's law.
Yeah.
Right. So then my question is,
So
can
if
you
I get-
identify the medium change in the first place?
I'm sure I can get metadata from somewhere.
Where's the change in medium, though?
Well, the density changes.
Can get.
Now,
so you haven't got it, so you're assuming it. So no proof, you're just asserting.
You're not
it by
arguing that there
assumption.
is no refraction, are you? Because that's a silly argument.
Sorry.
Because you have like dirty air and vanishing zone on your model.
On the horizon, as evidenced, as demonstrated, as visibly obvious. So you can
If you want to
see that
dispute
refraction.
how refraction works, you need to do a science degree.
Sorry, Dawn.
No,
I'll
you
just
don't.
say it
You
once
just need to
more, just
produce
for
evidence.
You do.
Just
No,
for
you don't. You
Dawn.
just need to produce evidence that is inconsistent with the claim that it refracts the way you describe it. The claim is that it bends light downwards, correct?
Generally, yeah.
Right. So how would you explain what we saw on Soundly's video where he had the 8 lights on the little Tensor Spy experiment?
I assume a temperature inversion.
But we saw the lights danced up and down, and they were independent of each other. They were not tied to each other. They danced sometimes up, sometimes down. How would you explain that with refraction that only ever bends down?
I just said it generally bends down.
So what we have in the case of the Isle of Man, then, is an assumption that light generally bends down to such a degree that it perfectly represents the island with absolutely no distortion, Dawn. So there's no visual effects, no evidence that this refraction's actually occurring on anything other than the stuff that we reference with evidence. It's obviously there, we can see it. Like most of the things we point out, it's there, we see it, we can demonstrate it, it's obvious. Your refraction,
people
however,
that would want to defend.
Ruhif has no evidence of it. He just assumes it. When we've asked him if he got evidence, he says, I'm sure I could go and get it. So no, he has no evidence of it. And yet we are expected to just accept that the rest of the island, with no visible or demonstrable effects of refraction, is entirely refracted. The entire island, 100% of it, is looming. So the entire island is affected by
crazy
this
place.
refraction.
That's what happens.
And yet there's
Hey,
no
Anthony.
obvious, demonstrable evidence of it.
We just got to make sure
will you
these theories
take a
match up with
theodolite to St.
reality.
Bees?
I mean, we just got to make sure these theories match up with reality, because if we see light bend this way like a hula hoop, we should see a rainbow effect, correct? It just begs the question. We should see a rainbow effect right on the fatter part of the light's arc. Is that correct or not?
I don't know. You haven't shown that.
Does refraction create rainbow?
Right,
Was, how you
Google
doing?
it.
Hey,
all right.
what?
Sorry, bear with me.
Go Google
Hey, Was, how you doing?
Was here? Yeah.
Hello, I'm real.
You're a bit quiet, but I'll turn you up. Good to have you.
Thank you. Good to be here.
And Ruhif, you had a very interesting, if I could share again, a very interesting diagram where you were basically figuring out distances to Polaris on a flat Earth model. And you basically said the distance would be so astronomical that the Earth can't possibly be flat because you'd have, like, what, millions of miles of distance to the vanishing point of Polaris or something like that?
No, I was saying on a flat Earth. So you understand the observation is that the latitude that you're at is the same as the elevation of Polaris.
Mm-hmm.
Okay. So if we take two observations, we can work out an actual height above the Earth that Polaris is at.
What I wanted to say was that your calculation would be an error because stuff would dip in the horizon from perspective in some flat Earth models. Our low height to the ground makes stuff disappear way before their true vanishing point. So that caused your calculations into question beyond that false vanishing point, making your calculations astronomically large and artificially large and impossible. So basically, your calculations cannot be quite trusted because stuff is dipping in the horizon from low height off the ground and vanishing at a false vanishing point, an apparent vanishing point that is not the true vanishing point.
Perspective does not change the angle of elevation.
But the only thing is, you would only get a true vanishing point if the object was at eye level. Now, the sun is way higher, which gives it a false vanishing point from low height. So that calls into question your calculations beyond that false point. That's all that I was trying to say.
Perspective does not change the angle of elevation at all.
No, but refraction does.
Well, yeah, but we've seen from what Mick West's video that refraction, like celestial refraction, is only in the last couple of degrees.
No, that's not true.
How is that not true?
Because A, it's coming from Mick West, that makes it by default a lie
Oh,
or
come on,
exaggeration.
champ.
Yeah, absolutely. And secondly, we can demonstrate the effects of refraction on stars. Would you like to see a demonstration?
Oh, is this? Oh, I'd love to see it. This is this crap, right? Bring it up.
You were going to cite this against me, and I realized it works in my favor. Right, so let me
hold
show
on.
my
That needs a bit more padding. So Ruhif shared this with you, did he?
Yeah, he used this against me initially. Yeah,
Excellent. Love it.
No. I've asked you to demonstrate whether this has any correspondence to reality at all.
Well, I've asked you to explain the 7.6R as you're citing 7.6R as a mathematical adjustment based on a radius of the Earth, and I've asked you to produce evidence of said radius, of which you have none. Now you're asking me to produce evidence.
Let's do Polaris again.
Say again, Ruhif. Sorry, that didn't come through.
Do Polaris again. Let's do Polaris again to work out the radius of the Earth.
No, all right. So moving on from your assumption. Okay, no worries.
No, we're not moving on from his assumption. Nathan, can you present my screen? On the left-hand side, we have the stars without any atmosphere whatsoever. On the right-hand side, we have stars with the atmosphere, and we can observe that as the stars move away from the horizon, there is a disparity between their actual position and their apparent position, a bit like the horizons from yesterday with Rumpus. So as they get away from the horizon, the only point where they're really without any real refraction is when they're immediately overhead. So basically, if you're going to cite that refraction can magically bend stuff from behind the curve, I can demonstrate on a flat plane how the stars can compensate for what you're claiming. Can you prove that they are right or wrong? No.
Oh man.
Sorry, you've shown a video, but have not shown any correspondence to reality with this video at all. Are you saying that a star that's 40 degrees elevation actual has an apparent elevation of 25? Is that what you're saying?
I'm saying that without any atmosphere, if the star sits at 40 degrees, because of refraction, we see it at 25, 26.
But do you? Do you?
How would you know? You'd need to be outside of our realm to see that, right?
Oh, you can easily measure the sun going across at 15 degrees.
Yeah, but if you're going to argue that refraction bends light from round a curve, then I can argue that the stars are not in their actual position; they're in an apparent position, and neither of us can prove otherwise.
Yeah, because that makes sense.
No,
well, I mean,
let me say it again. Let me say it again. For the benefit of Dawn, if you're gonna claim that light bends around the curve of the Earth because of refraction, then I'm going to claim that the apparent position of stars is not the same as their actual position.
I know.
Because of refraction
Doesn't make sense.
If you're going to use refraction to claim nonsense, I can do it too. Can you prove me wrong?
And we can make assumptions that could be wrong. Like maybe we have a dome and the light is reflecting off of a curved dome, and that's the only real refraction that there is, just the light hitting the dome and coming back around. Maybe that's the only refraction, quote unquote, that there could be, the light, just hitting a dome and that might be some of the effects.
Sorry, bear with me. Hey, doing Ned? Good to have you. Can you hear us?
Yep.
Good to have you.
So I'm glad Riley's taking it into the heavenly bodies because they're quite strong globe proof. They get very messy on a flat Earth, don't they? Heavenly bodies.
No, that's all. We just use refraction to magically make them all better again. The same way that you do for them straight lines that need to bend.
Can I ask a question about that, Riley?
Absolutely.
So if the sun appears to be moving across the sky at a particular steady speed, yeah?
Yeah, 15 degrees an hour, I believe.
Yeah.
Yes.
So when it hits the refraction zone, shouldn't it jump or move or do something about the speed? Shouldn't that change?
It does.
No.
Yes.
It does.
Why not?
Are you talking about the refraction zone horizontally at the horizon?
I'm talking about whatever refraction zone you're talking about.
Well, we can just make it up to suit your answer because that's what you do with refraction.
Well, then make it up.
Okay, I'll make it do whatever I want with a bit of maths. So what do you want me to do?
I want to know why the sun doesn't appear to jump in speed when it hits the refraction zone you're talking about.
Do you have any evidence to show that it's got a constant speed?
The refraction zone. Sorry, I've got to say this again. It does do crazy stuff at the refraction zone.
Anthony.
You just said what it was, I believe.
It does do crazy stuff at the refraction zone. It does do crazy stuff at the horizon. That's what is easily demonstrated.
I'll just make a bit of maths up to compensate it. We can do anything we want with refraction. We don't have to base it on any real evidence.
Will your maths match reality, Anthony?
We got
all right. Let's work on the dirty air refraction zone.
Well, let's just ask you, Globe, as a quick question then. Sorry, is it not acceptable to assume refraction things that we say they're doing with the stars? Is that not okay to assume that?
Say it again.
Nathan,
Is it
you did not
okay?
ask for evidence of Riley's claim, right?
Is it not okay to assume that refraction is affecting the stars in the way we are assuming it does?
Yes, but you did not ask Riley
yes?
for evidence.
Is that yes? It
of
is
his claim.
acceptable to.
Well, I
is
gave
it
evidence. I
acceptable?
showed you a model.
Sorry, it's
What
lots of
got-
talk
That's
over
not
going on.
evidence. Come on.
Let's
Here's
just
a
ask the
photo.
question one more time. Sorry. Is it acceptable to assume that refraction is having an effect on the stars? Is that acceptable? Yes or no?
Can you say that again? I didn't hear you cut out.
No problem. Is it acceptable to assume refraction is affecting these targets, the stars? Is that acceptable?
but-
Yes or no?
You don't need to assume it. You need to provide evidence.
Excellent. Exactly our point with R. So, Neg, do you have scientific proof of this R value?
Right, can I cite Mick West as the
Hold on, just want
authority
to get an
for
answer from Neg.
refraction?
Just want to get a quick answer from Neg. Neg,
No,
do you have
Riley, you can answer Nathan's
scientific
question that you
proof?
reflect.
It's all right, I'll just pop you on mute so I can get the question nice and clearly. Whether or not you listen is entirely up to you. The audience will hear it nice and clearly regardless. So, Neg, is it or is it not acceptable to assume that refraction affects these targets?
Look, here's the thing. It's not very interesting from an audience's standpoint to see you hypocritically hold them to a standard you're not holding Riley to.
I'm not asking anybody to hold us to
You
any
can
standard.
hold Riley to your standard.
No, I'm asking you if it
Yes,
is
yes, you
or
can.
is not acceptable to assume that refraction is doing things to these targets. Is it acceptable or not?
Well, I'm going to assume that Riley does not have the evidence that you hold them
Yeah,
to,
that would be
and I'm going to
what
let
an
them
assumption
continue to
is.
answer your
That
question.
is
I just
what an
wanted to-
assumption is, Neg. That is by definition what an assumption is. Asserting something without having actual proof of it. So we will all concede that we understand what the word assumption means, and I'll ask it again. Is it acceptable to assume refraction is affecting these targets? Yes or no?
I'll ask it in an even better way. Is it reasonable to assume it when we don't see light bend? I've never seen a bending laser. I've never seen it bend in a curve. I've only seen straight light. Can somebody show me bendy light?
Still haven't got an answer from
How do you
Neg.
know that it's straight?
Just need an,
I thought
just
your
need a quick
photos
answer.
of
Sorry,
Bambi
Rufus,
are
sorry, I'm not going to let you all
And
obfuscate
other
this point.
experiments.
Sorry,
bending
just
light.
don't obfuscate this point. I would like an answer from Neg. Is it acceptable, yes or no, to assume refraction affects the targets we are talking about, in this instance, the stars? Is that acceptable, yes or no?
No.
Yeah.
Hold on. He's going on and off mute, but he's not saying anything.
No, like I said, all I wanted to do was to have you hold these two gentlemen to the same standard you're holding your own side to.
Well, I'm establishing what
Right.
standard
So
is acceptable.
why would you
Neg.
assume something when you can measure it? That was their point, that you can measure that the stars do not.
Excellent. So we don't need to assume that Earth has a radius. We don't need to assume it. We can presumably prove it. Correct? Is that not correct? We can just ignore this assumptive nonsense about assuming refraction is affecting the stars, and we can just prove it, right?
Well, I mean, by your standard, you're
Hold on,
saying that we
Arif.
can prove
Hold
it
on,
by...
Arif. I'd like Neg to answer. He's saying we should prove these things rather than assuming them. I just want to clarify that's what he's saying. For the audience's benefit, you can see Neg sat on mute. Please don't anybody answer.
Hello? Hello?
Philip, just give us a second. We're waiting for
Hi.
Neg to give us
Okay.
a clarification on whether or not it is
Sure
acceptable
thing.
to assume that we have refraction affecting targets. Is this acceptable or not, Neg? You just seem to be sat on mute, my friend. Difficult question, Neg?
Don't think he wants to answer.
No, I don't think he does want to answer, but I'm more than happy to just sit here, watch with the audience seeing him sat on mute while he ignores my question, which is pretty much what he did last time he came on.
Oh,
Hey guys,
what the audience is saying is you failing to hold your own side to the same standard and then asking me a nonsensical question that's already been answered. That you don't need to assume when you can measure. And that was their answer that they gave you, and that's the answer I'm giving you because it's the answer that makes sense.
So
why
what
assume when you can measure? Is it
acceptable to assume anything or not?
So why would you hold Riley to a different standard than these two? When he makes a claim, you ask for no evidence, right? You said it just like that.
I'm asking you what standard to hold him to, Neg. You don't seem to understand the question.
I'm going to sit here until you provide evidence for his claim.
So we have to have evidence. This is excellent. So we do have a concession from Neg. It is not acceptable to assume things. We must have evidence for them. Excellent, Neg. Thank you for that concession. So, when it comes to this refraction, we will assert, as I've done for the last 2 days solid, that we must have proof. No more assumptions, Neg?
Okay.
It's only acceptable to prove these things with evidence. As Neg likes to parrot me, I'll parrot myself. Yes, that's right, Neg. We require evidence rather than assumption. Excellent, excellent concession, Neg. Thank you for being here.
Can I please provide evidence for light bending down?
Yeah, there's plenty of videography available for you to have a look at it.
Huh?
We know light bends down.
Yeah,
standard refraction, usually land-based, induced by heat.
So, Philip, did you get my message earlier this morning? Did you get my message this morning?
Yes, I did.
Excellent. So, do you have scientific proof of this R value you use in your modelling?
Do I have scientific? Well, I don't really care about talking about the globe model. I care about matching models to reality.
Sorry, that's a no then. You don't have scientific proof of R. You're saying you're trying to match it to reality, but in your reality you have this assumption of R, correct?
Yeah, sure, we can go.
Right, sure. You have an assumption. Neg has just quite clearly made it stated that it's not an acceptable standard, Philip, to assume things. You need to prove them.
Actually, the evidence presented was the degrees that Polaris changes based on your latitude, which is 1 degree per 69 something miles.
Annoyingly loud. Let's just turn you down a bit. There we go. You carry on.
Right. So if Polaris moves 1 degree for every 69 miles you move on Earth, you can then determine the radius of the Earth.
No, you can determine the angular change of the heavenly bodies in relation to the surface span of the Earth. That's what you can determine.
Do you know any trigonometry, Owen?
Yeah, I know.
Sorry.
Well,
you can keep on bringing that in, but that's still a deduction based on assumption of knowing the size or distance.
Arwin, hold on just for a second, Arwin. So, Philip, just got to the point where I was asking you about this R value that you assume in your model, and Neg's made it clear that we don't make assumptions about things. So I'll ask you again. Do you have proof of this R value?
Yeah,
we
just
proof.
Stated it. Sorry.
Nick, don't need your name proof. Is not Nick. You've already given us a concession, Nick, that Nick needs to adhere to now. We don't assume things. We're not allowed to assume that refraction is affecting the stars, as Neg pointed out. We need evidence. So I'm now asking Nick for the evidence of R.
But why do we need evidence?
Why do we need evidence? Well, because when we're trying to prove things, evidence is the standard that generally people would absolutely expect. They don't expect assumptions, Philip. They don't expect you to just presume things are happening. They don't expect you to presume that the Earth is a sphere when you're trying to prove it's a sphere.
Well, let's presume the Earth is flat then. And when we do that, we see that
that's not what we're
observations
doing.
do not match.
We're talking about sphere Earth for a change. We're talking about the sphere Earth.
No, they
Everybody
don't.
seems
I
to
have
think they live on,
evidence
Philip.
showing that they clearly do not match.
They do. They make sense. They match.
No, they don't.
Couldn't care less if they match
do.
or not. Matches with what? Matches with an assumption that you're on a sphere, and matches with an assumption that light bends around that sphere.
I don't care
with no
about what the sphere predicts.
evidence.
I care about what the flat Earth predicts.
All right, well, today we're talking about the globe and how it has no evidence, Philip. That's why I sent you a message in advance of this show.
I don't care.
Oh, well, get off the show then. That's what we're talking about today, Philip. We're talking about the globe and the fact that there's no evidence for it. There's no evidence for this R value that you put into your model.
Nathan, I don't really care. I really don't care.
Yeah,
all I care about is what
doesn't
models
really
match
help.
reality.
We do
And
care. We do care about
flat Earth
scientific
models
evidence.
do not
That's what
match
we care about. You don't care that you don't care.
Your model's based on assumptions with no evidence. Don't you get it, Philip? That's the point we're making here. If you want to model something based on a whole bunch of assumptions, it's meaningless.
They're not assumptions.
Sorry, we've just established that this R value has no proof, Philip. So we've absolutely, in this show, demonstrated to the audience that you are assuming this radius. You don't have proof for it.
Do you have proof that the Earth is flat?
Sorry, that's just asking me the question. This is a globe show about whether or not you've got proof of the globe you assume. That's what we're doing here. Yeah, we've done the flat Earth.
We're no longer arguing
we've done the flat Earth proof for many shows and talked about it. Now we're holding you to account for your model and your bullshit. Now we want your proof. Evidence. We've presented it, and all you seem to want to do is tell us to go to the beach again. No. Now we're talking about the globe, and I want some proof of that. So you guys say, we've proved you wrong. We've shown how your guys, your models, they don't match. Why?
So why
because we assume that there's a curve. Not only do we assume there's a curve, we assume light's bending around it. Half my guests have been kicked out. What's going on? Oh,
please tell me why North Barul is higher than Snæfell, observable in images.
Sorry.
I don't know. I don't know.
Yeah, I don't know either. But if you're going to tell me that it models perfectly with an assumed curve and assumed light bending around an assumed curve, I'm going to say it's completely nonsense. You guys are all going to have to join a different hangout because half my guests have been kicked. I don't know why.
Yo.
Hello. How you doing? I don't know what happened there.
I'm better now. Can I share my screen whilst I get a minute?
Yeah.
Oh, hang on. Let me just get rid of that noise. What's that noise? There it is. Right.
Nice
so
nice of Neg to concede that we need evidence of stuff and we can't just presume things. Nice. Thanks, Neg.
All right. So people were asking, why is it that Nathan's not asking me for evidence of the claim that stars are subject to refraction? He's got a fair point, but Nathan knows damn well that there is the evidence that stars are subject to refraction because it's where the basis for this terrestrial refraction starts from. Yeah. I'm citing from metabunk.org, and it's Mick West himself, your Lord and Savior. Atmospheric refraction is measurable when observing stars. Now, obviously, when we're looking at terrestrial objects, we do not observe anything outside of our domain, whatever that domain may be. So observing stars in the first place to make a refraction adjustment is nonsense. However, he claims that we see refraction when observing stars. Stars visually appear to rotate around the Earth, blah, blah, blah. When they reach the horizon, their actual calculated position is a bit over 0.05 degrees below the horizon, which he basically describes that as negligible. Now, I'd like to know what's the evidence of to prove the scale is, because he does put a video, I'll show it you in a sec. But basically, he says that it's a bit more than the diameter of the sun. So what he's saying is that stars are subject to refraction. And then a little bit further down the page, he has this little video. And basically what he's showing here, I'll make this bigger if I can, that one. what he's showing is time-lapse photography of the stars as they get towards the horizon. And obviously, when you do long exposure, you will see the lines, hopefully. Let's speed it up a little bit. Now he's showing the lines, and what he's showing is that the stars are shimmering as they get towards the horizon. Now, that deals with the left to right refraction, but with regards to the up-down refraction, where is the actual position? We see bent light. We know that refraction is a thing. The question is, what's the effect of it? And look at this. Look at the distortion here, and you can see that at the top of the page, it's pretty much a straight line, but it starts to become affected by the refraction pretty quick. And the argument is
all jittery in its path.
Yeah, and the argument is, of course, that the only real time when you don't see any refraction effects on the stars is when they're at 90 degrees. So what's the effect of the refraction on stars? But in any event, doesn't matter. There's the evidence that stars are subject to refraction. How much is the million-dollar question? But remember that the 7.6R basis is based on the astronomical observation of stars. It has nothing to do with what we are observing on the plane, be it ball or round or flat. But there's the evidence, boys and girls.
That's interesting stuff. Also, yeah, we'd have to assume that in that was a great video, by the way, that even the stars that do go down, that they eventually do move into the actual refraction zone. Because the apparent horizon, no, even if you are looking very high up, is always going to be a little bit further than the apparent horizon. As we discussed yesterday, that counts for eye height observations, for land-based eye height observations, but also for very high observations. So maybe when the stars in the final part of as they are approaching the horizon, that they're actually moving into that one zone that tends to mirage things, that's causing the jittering in the final part of their path.
Now, I've produced evidence that stars refract. I'd like to see some evidence for the status, not the 7.6 bit, but for the R part of the calculation. So if there's any ballers that can produce evidence for the R, because when challenged, I produced some evidence to show that there is star refraction. Can we see some evidence of the radius, please, of which you all adjust for? And it was actually Ruhif that made the claim. He's now not coming back. He's going to bed.
Yeah. It's funny because technically all things that are visual should have refraction applied to them. All things. It's all a matter of how far distant they are and how moist the air is, basically. How much refraction there would be, it would determine the distance at where the refraction slant starts to occur. But all things visual have refraction applied to them.
And I'm going to make a claim, I'm going to make an assertion that it is claimed by science generally that the only time that stars are not subject to refraction is when they're immediately over your head. That's the claim by science. And unless somebody can show that that's not true, by, in other words, debunking science, then that is the current science. So, again, there is evidence of stars. So where's the evidence for the curve, the radius? So maybe Sly Sparkane could do some, because he's in chat, being a keyboard warrior.
Roll up.
Let us know when you put the link up publicly.
Poke the trolls for only a penny.
Poke the trolls for a penny.
Yep.
No, to be honest, I kind of sort of agree that stars high up and all things pretty much higher up, directly above us, should have at least less refraction applied to them, as the total air density you're looking through is going to be less than on the horizon.
Correct.
But it's not going to be completely gone, because, yeah, that's impossible unless you're in a vacuum. And that's
true, but that's what science claims. It says at 90 degrees, the refraction...
It might become completely negligible in that sense, but it's never gone. Never.
Right, I'm going to do a quick link, and then I'm going to put the link out publicly again, as we've had about 5 minutes of chat uninterrupted. So if you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it's live, and a link in the info box once the video has rendered. But most importantly, if you would like to join the panel, simply click the link in the info box below this video. Be sure to mute your watch page before you do so. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show, as sharing the show increases the chances of a more diverse panel. As I say, there is approximately 1 hour left on this broadcast.
Oh, by the way, has Rumpus found his proof for the scientific evidence for the curvature yet?
No, but he did provide a journal reference that Nathan was going to have a look at, but he's not here to respond to. Nathan, have you had a chance to look at it?
I had a quick look at it, yes. Doesn't fulfill the scientific method.
That reminds me. I'm sure I've just seen Sean Hufford in text. I might not have done. He's put a video out basically saying the gist of it was, what evidence would Nathan Oakley accept as scientific proof?
Hello.
Hey, Ranty.
I was.
Good morning.
Hello.
Good afternoon.
Ranty, could you keep an eye on the back door, mate? Because my battery's just gone flat on my phone. My thing, I'm trying to get a replacement sorted.
Chibi Jedi Sock killed everyone up.
Sorry.
I was going to kill him, but I thought you lot might be mad.
Not at all. You know, I can't control who snipes who, unfortunately. Hey, Alex, good to have you.
Alexander. Hello, Alexander.
Hello, can you guys hear me?
Yes.
I can indeed.
Okay. I'm sorry, I'm a little bit sick.
Anthony?
Yeah?
I thought that that video you put up before, it shows the time lapse of the stars refracting at the horizon. If the Earth was a globe, wouldn't you expect that with the stars outside of the atmosphere?
If the Earth was a globe, would you expect that outside of the atmosphere?
With
Hey,
the
there
stars
is no outside of the atmosphere.
Just say a quick hello, Arav.
No.
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 Oh.
No.
There is no outside of the atmosphere.
You can't say that, Alan.
Remember all that footage, even from NASA themselves, of going high up and then not seeing stars anymore? How many globe pictures are out there with stars surrounding it that are
that's fair enough.
recorded as official pictures? How many of them actually have stars surrounding them? Why do you think that is?
And that's fair enough. But there have been many flat earthers as well, and I know of one in Canada who has sent up a high altitude balloon, and he's got out of the atmosphere.
Oh, really? Oh,
hang on a minute.
Sure, there's proof of that they went out of the atmosphere.
All right, hang on. Do you know what?
Do you know what the stratosphere, whatever you call it, but it was 110,000 feet.
Hang on. Do you know what escape velocity is?
110 to 120,000 feet. What's that part of the atmosphere called?
It's one of the ionospheres or something of that nature.
I'm sorry, but 120,000 feet, that's 35 kilometers. That's still.
How does a balloon escape the atmosphere? That's...
Sorry, can you just say that again?
It sounds like he's assuming that it's outside of the atmosphere because it's dark, but it might be dark because all the air has.
Bear with me. Can you just say that again, Alex?
And
sorry.
It's in a black space under the dome. I mean, there are many assumptions you could make with that. It might look like it's in space, but it might just be above the normal air's density zone and in a black zone. That's it.
Sorry, what layer is it, Alex?
Put it. That's a good altitude to see if the Earth is curved or flat, is it not?
Hang on a sec. Can you share my screen, Nath? I'm going to challenge what you just said there before you give any evidence for it.
I want Alex to be able to get a word in edgeways, because at the moment he's not part of the conversation. He's just getting talked over constantly.
Yeah, I mean, you guys were talking about the proof that you guys demand for the Earth's circumference, right?
Radius.
Yeah, radius. I mean, you can convert one into the other.
Well, we're actually specifically asking for the radius.
Well, if you know the circumference, you also know the radius.
That's fine.
Yeah.
Is
you
the
can have a
scientific proof
circumference
of the
without a
circumference?
radius.
Is the scientific proof of that? Is the scientific proof of that? Excellent.
Yeah, there's scientific proof of that. It's quite easy to do, actually. You just need 3 observers on different latitudes.
Sorry, what do you mean, do?
Well, to measure it directly.
No, I don't want to measure it. I want you to present scientific proof of it.
Yeah, what do you think scientific proof in this case is? You have to gain data, and that's what measuring is.
No,
but you have to verify data.
Describing what I could do if I was to follow the scientific method. Hi, Sarks, can you hear us?
Yeah.
Good to have you. Can you say something else?
Thank you.
How can we help you, Sarks? Clearly we can't. Goodbye.
Yeah, because Sarks is a real bad hater in chat as well.
Right, you need to say more than just hi. You know, if you're here, you need to be here for a reason. So, going out and doing things isn't the scientific method. It's following the scientific method going forward. That's not providing scientific proof of this radius.
That's not correct. You're measuring data, and if this data is verifiable, meaning that other people can do the same experiment and get the same results.
So how long have we had of globe understanding, Alex?
What?
How long have we had of globe understanding in years? Give me in years.
2,500 or so at least.
So you're saying that after 2,500 years, I can now, going forward, go out and acquire this scientific proof? Or
no, you could have done this 2,500 years ago if you had the proper equipment.
Excellent. So show me this 2,500-year-old experiment that adheres to the scientific method, please, Alex.
Yeah, sure. Again, you need 3 observers.
Sorry, this is not you presenting something that I can now go and do. It is you presenting scientific proof of the Earth's sphericity.
Can you see my screen?
Yes.
Okay.
Yep, you're up.
So this is
scientific proof?
Yeah, let me explain it. Let me go through this step by step so you guys understand this, because I have the feeling that you're very slow in this.
No need for the ad-homs.
You don't understand what scientific proof means.
Are you fucking kidding me?
Oh, come on, don't swear.
No need.
Anthony, you know that I'm literally studying to become a scientist. I'm doing a master's.
I couldn't care less, Alex.
Tell us what scientific method is.
I couldn't care less about your white coat qualifications. First,
well, hang on.
What phenomenon are they observing, first of all, Alex? What's the phenomenon? Then you can tell me what the alternative and null hypothesis is, i.e. what is the cause, the independent variable. You can tell me all this. Go through it.
Okay, so we have the 2 models that are currently under investigation, whether the Earth is flat or not. Flat or spherical. Those are the 2 models that we're trying to figure out which...
Sorry, no, Alex. No. 2,500 years of globe understanding. So we're not trying to figure this out. You should know and be able to present scientific proof of it. Not going forward.
That is exactly what I'm trying to do, if you would actually let me.
So this is going to be a presentation of scientific proof of Earth curvature?
Yeah, pretty much.
Pretty much? So after 2,500 years, the best you can do is pretty much?
And what
Alex, it needs to follow the scientific method.
Hold on. Let me just get an answer. Is this going to be an adherence to the scientific method that you're about to show me, or not?
Yes, it is.
Yes, you seem to have gone a little bit high pitched. Are you sure of that?
And my voice is always high pitched. You should maybe know that by now.
Not anymore. Not anymore, since I pointed it out to you. So, do you want to start by showing us what exactly is their phenomenon that they are observing?
Okay, what we're looking at is the angle towards the pole star. That's the phenomenon that is observed during this experiment.
Sorry, this is not Earth curve, is it? This is a star.
Yeah, so what?
Sorry, are you dense, Alex? Do you understand what I mean when I say I want scientific proof of Earth curvature?
Yes, and you can derive one from the other.
So this is not scientific proof. This is a derivative proof. So it's a derivative proof using the stars.
No, it can't, and I'm going to show you why.
No, this is not scientific proof of Earth curvature in any way, shape, or form. That's
why
it went all high-pitched. You know it's not, and I know it's not.
Let me go through the experiment to show you why.
I don't want to know why.
You're not being a very good scientist.
I've just asked you what phenomenon they're observing. It's nothing to do with Earth curve. It's to do with the star. So fail. First hurdle.
Do you agree, Nathan, that when the surface you're standing on has a different geometry, the angles or the angle towards the stars is going to change dependent on that?
So you would first need to prove that we have geometry that we are stood upon, which is precisely what I'm asking for.
Yes, and that's what I'm going to do.
No, you're going to beg the question and assume that we are already standing on a sphere.
I'm not going to assume anything. That's my point. I'm not assuming anything during this experiment.
All right, let's see what he doesn't assume then.
So Nathan, are you willing to give me the time to present this, or are you going to interrupt me every sentence?
Let's hear the rest of the scientific method that it applies. So what's the...
Yeah, let's hear it all.
What is the independent variable?
The independent variable.
You don't need to repeat it back to me. You need to answer it, you dense little man. What is the independent variable? I don't want you to repeat it back to me. Tell me what it is.
It's the distance between the observers.
Okay, what's the null hypothesis?
The null hypothesis. Well, when we're taking a look at.
Are you deaf?
Hey! Let me explain this. Goddammit!
Don't take the Lord's name in vain. You don't have an answer.
What the fuck? Seriously, why?
Oh God, you can't be on.
Okay, let's calm down. This looks like a very good experiment. Let's check it out.
Okay, I already told you.
I'm not interested in this. I'm not interested in experiments.
Various different...
I'm interested in scientific proof of Earth curvature. So far, I've taken him through a couple of steps of the scientific method. We've got a bit of a high-pitched answer, and then no answer. So far, this is not a scientific proof of Earth curvature.
Yeah, because you don't let me explain my experiment. Or this experiment. It's obviously not mine. It has been done before.
No, I want you to show me the adherence to the scientific method.
I already did.
No, you didn't.
Oh, yes, I did.
No, you didn't.
Why not?
I already told you that this experiment is repeatable. It will yield the same results, no matter how who is going to do it.
Show it being repeated. Show where it's been repeated. Has it been repeated? Or are you telling us to do this going forward?
I'm saying it's easily repeatable.
Easily repeatable or has been repeated?
I'm sure it has been repeated.
You're sure?
Yes, because otherwise navigation wouldn't work.
Have you got a repeated version of it with you now?
Yes, no.
Well, go away and go and get it. Simple. If it's been repeated, and you're pretty sure it's been repeated, go away and get that as well. Okay? Is that okay, Alex? You can go away and get an actual scientific proof of Earth curvature, rather than something that is using an extrapolation based on the stars.
I'm telling you, there's no assumptions made there. Everything that is done there is measured directly. There's no assumptions in there, and it will only yield the direct result for the flat Earth or for the globe. Nothing in between.
The geological changes.
Can I ask a question?
Sure.
What's the how's the atmospheric effects of refraction been calculated or adjusted for in this model?
It doesn't have to be, as long as you're not close to the equator.
Why does it not have to be?
Because when we're taking a look at angles that are pretty much directly overhead, when you're at the North Pole, the pole star is obviously directly overhead.
Right. And where would your other two observers be?
Well, the further north, the better in terms of the refractive effects, but it's pretty much forgettable. As long as you're not placing one observer directly on the equator, it's no use even for it.
Because you have two assumptions. One, an Earth spinning relative to other things that aren't spinning as much as the Earth.
No, I'm not talking whether the Earth is spinning. Whether the Earth is spinning or not is irrelevant. Whether the Earth is spinning or not is irrelevant. We're only using
the base assumptions.
Basically, no, that's not correct. That's not correct.
Would interpret your data through. So if the dome overhead is moving, you might get something very similar to an Earth moving through space, depending on what theoretical framework you
can y'all stop talking and let him present what he came here to present?
That would be nice.
Can you do that?
I'd like to see it, yeah.
Okay.
Yeah, me too.
So, but first, we're only taking a look at the angle towards the North Star, and that one is fixed. It doesn't move during the day. So whether the Earth is spinning or not is irrelevant for this experiment. It only proves the shape of the planet. That's all it does. Whether you want to argue it's spinning or not, that's a different thing. You need a different experiment to determine that.
Well presented then.
Okay. So let's go to the North Pole. So that's 90 degrees overhead. 90. Okay. So as you can see here, see, how does this work? Azimuthal coordinate grid, nice. And obviously, we just switch off the atmosphere because otherwise I can't see the stars themselves. So we get the pole star pretty much directly overhead. That's 90 point. Sorry. That's. I turn this one star. So that's 89.2 degrees north. Okay. See this. 98.15. So we can measure an angle when we are on the North Pole. We can measure an angle between the surface of the planet, atmosphere, ground. Yeah. So the surface of the planet is here at 0, and the pole star is at 90 degrees, pretty much directly overhead.
Right, I get it.
Okay,
so,
and
so
we
let
can...
me presume for just a
Hey,
second that
Arwen,
it's going to be
please...
based on the angular difference of the star positions in relation to the Earth position again.
Arwen, stop.
Yes, that's pretty much what
Yeah,
it is.
well,
But allow me to
that
present
is
it
not
first.
new proof. That is nothing. That's the same thing over again.
Well, I never said
It
it's
doesn't
new, didn't
prove
I?
the shape of the planet. It only proves that there is an angular difference
No, it doesn't.
of the stars in relation to the Earth position. Yes, it does. That is the proof that you're going to present. But go ahead.
Let me go through this. This will take
Alex,
some time,
ignore
but
me.
it's
Carry on.
But it's going to prove that the Earth is a sphere, or pretty close to a sphere.
It's probably not. But go ahead.
For fuck's sake. Sorry. So I've just changed my position to 80 degrees north. As you can see now, the pole star is approximately at 80 degrees. Zooming into this. So Polarstern in German is the pole star. And as you can see, 80.4 degrees. And we can do the same thing over and over, 70. So we're now at 70 degrees north, and the pole star will be at 70.4. Same with 60, 50, 40, and so on. I'm just going to use 50.
I'm sorry, Gio, this isn't going to prove a sphere.
It is.
That's actually right.
Not even close.
So I'm now at 50 degrees. This is pretty
just
much
numbers, isn't it, to them?
Hey!
No, it's angle differences. It doesn't prove the shape.
This is incredible.
Yes,
so,
it is.
Oh my God, Arwen. So I'm now at 50 degrees. This is pretty much where I live. And you can see the pole star will be at somewhere between 50.4 degrees north.
Right.
Okay. So what we now need is a geometry program. I'm going to use GeoGebra. So this is a simple geometry program.
So can I just clarify? Are we at the point of the scientific method where we are making the hypothesis, or is this the point of evidence where we're proving that it's true?
Well, we've gathered the angles, and now it's time to test whether they fit the spherical model or the flat model.
No, I thought we'd just done that. I thought we were just getting.
What's your null hypothesis?
Well, the null hypothesis is that the Earth is not spherical.
That's a crap.
So if you
crap null hypothesis. So what's your independent variable?
I already told you.
Yeah, but hang on. If you were going to be comparing it to a null hypothesis, surely you would have two models where you would say if the Earth was spherical, this would be the angle, and then if the Earth was flat, that would be the angle.
Yeah, that's what I'm going to compare to one another now.
Okay.
Those are the two cases. So I'm going to actually do this to scale, which will take some time, but I think it's worth it. So here we have point A. That will be the North Pole. Okay. I'm just going to place the point at -12 because I will have to have a line that is parallel to the x-axis. Okay. And what I'm going to draw in now is the angle towards the pole star.
Is that the
which was directly over? Oh, wrong function. I need that one.
Well, he's already said he's just going to invoke sky refraction.
Directly over
anything that we say.
Hey, Tim, how you doing? Good to have you.
Hey.
So as you can see,
that's him.
So this line, which
you can finish this feeling like you proved the sphere, and Riley's just going to revoke sky refraction.
No,
but there's two things.
It's all about angular differences and the base assumption of how distant these stars are.
Actually, it isn't.
It's always assumptions
you understand it perfectly,
without any proof of the actual distance or the actual size of the stars. So
the size and
it can work on a flat Earth model. It can work on a globe model.
Arwen, let me present this, please. So now, point A.
I still don't know what the independent variable is, so I still don't know what the cause is. What's the cause?
I'm going to show you.
You're going to say the cause is the Earth is flat? That's the cause?
No, what I'm saying now, so this
do you understand what a
diagram
dependent and independent variable is?
For fuck's sake, Nathan, please let me just explain this.
No, I want to know if you're adhering to the scientific method, and therefore I need to establish if you understand what a dependent and independent variable is. The cause and effect. That's what I'm trying to establish in your experiment. What is the cause and what is the effect? That is what I'm trying to establish. That is why I've asked you multiple times what your independent variable is. So you don't seem to want to tell me. You just seem to want to babble on, carry on showing your evidence without actually showing your adherence to the scientific method.
He did tell you already, Nathan. He did.
Yeah,
so Nathan, let me present this. You said I would be able to present this. If you're continuously interrupting me, there's no point in doing it.
Well, you're not showing your adherence to the scientific method.
I am.
No, you're not. So that's why I keep asking you to lay it out in a format that is adhering to the scientific method. You just keep going to your observation. That's all you're doing. So you need to lay it out.
Nathan, what's with the double standard? I mean, have you, Ranty, or Riley ever used the scientific method? And matter of fact, have any flat earthers ever posed the scientific method?
So what we're doing here, though, Tim, is we're establishing that you have had 2,500 years to acquire scientific proof.
That's the flat Earth scientific method in the.
Well, you've had 2.5 years and you haven't done anything.
$50,000 laser in the face.
How long we had, Tim?
Flat Earth does scientific
How long have
method.
Sorry, Dawn. How long have we had, Tim?
You've had about 3 years to even do it once.
Well, you guys have had 2,500 years to come up with scientific proof of Earth curvature, according to Neg and Geostreber.
We have
You've had more technology.
So you're obfuscating what I asked.
In the last 2.5
I didn't. I answered
years.
your question.
You've
You
had
said,
more
do we
technology.
adhere to the scientific method in the 2 or 3 years that we have known this information? And I answered you, no, we haven't. What I'm asking you guys to do after 2,500 years is demonstrate what you've got so far to prove
we have
the Earth's
satellites
sphere.
in space, Nathan.
Yeah, okay, Dawn.
Can you guys please stop changing the subject so I can present my stuff?
Yeah, you haven't presented your adherence to the scientific method, Geostreber. How many times have I got to say it?
So you're not listening again to what I'm saying.
You want to share my video in the chat, Nathan? That's the flat Earth scientific method there. $50,000.
Nathan, will you, Ranty, and Riley be using the scientific method from now on then? Since it's a big deal now?
Guess we'll maybe have to. Maybe we'll have to present better proof. Yeah, you're right,
Sweet.
Tim.
Yeah.
Okay. Thanks.
No worries.
So Nathan, please, are you still sharing my screen? No, of course you are not.
No.
Please share my screen again.
No, you talk me through how it adheres to the scientific method. You lay it out, then present it. Tell me how it adheres to it.
Yes, I already told you.
So go through it again. Should be dead easy.
Okay, this is the last time I'm going to explain this to you.
That's it there, the scientific method. Flat Earth laser in the face.
Okay, so again, we've done the measurements of the angles from different positions.
Right in the face.
Yeah, you got the angles.
$1,000 laser.
You got the angles in relation to the position of the Earth. So
yes, okay.
Proof is fair.
What's that? What's that?
Hey.
Of the Earth. So
yes, okay.
Proof is fair.
What's that? What's that?
Hey. Okay. So now again, Arvin, because I think you're the only one listening right now. Can you share my screen? Or at least, Arvin, can you see it?
Yeah, I can see it.
Okay. So we're now in different positions on the planet. It's known that if you go 1,000 kilometers further south from the North Pole, the angle of the North Pole towards the horizon is going to change by 10 degrees. Now,
North Pole star, yeah, I know.
Okay, and there's a linear correlation between the distance to the North Pole and the angle change.
Yes, there is, indeed.
Okay, good. So what you get when you overline the different lines, so this here was the North Pole, this here was 80 degrees north, 80 degrees north, so 1,000 kilometers further south from the North Pole, the angle towards the pole star from the horizon would be 80 degrees. And I picked this example of, this is pretty much the position where I am at 50 degrees. The angle towards the horizon from the pole star will be 50 degrees. Yeah. Now, when you take it through, so these lines represent the direction of sight, or the direction you're looking at towards the North Star. Yeah. And you can see that they don't intersect. You see that? You have one intersection point there, one here, and one there.
Yeah.
So,
okay.
What
that
is
means
the North
that
Star? What's the North Star again? What is it exactly?
Well, wait, come on, Nathan. Let him finish for a moment. He's almost done.
Okay. So, sorry. So, when you're taking a look at the North Star from here, you expect it, from here, you expect it to be somewhere on this line. And when you're here, you're expected to be somewhere on this line. Now, the point that this proves that the Earth is flat is that those lines don't intersect. Not at all. If you do this for further points,
no,
for example,
that's based on the assumption that it is at an actual measurable distance.
Yeah, that's
no,
what's the North Star? That's
the
why
thing is, the whole thing
North Star?
about the star heavens is
what are we
that
measuring?
You got the
exactly?
angles.
Alex,
you got the angular position, and that's it. You don't have any physical proof that they are actually at a certain distance, no matter the model.
If I were claiming they were at a certain distance, right, then I wouldn't have drawn in lines. What I'm saying is those stars can be anywhere on that point on those lines, as seen from any particular vantage point.
They could be, but you don't have any proof that they are. They just seem to be in that direction.
Seem to be. Apparently,
and
they
that
are.
angle.
Just look and guess that what it is and why it is, and just assume
well, if you're saying that's not the or that that's not the case, that the stars are in different directions from different observers, or that they're actually at different positions, as seen from different observers.
They can be observed at specific angles, but that's it. You can't actually prove that they are physical objects out there in that exact point.
But what we can claim, or what we can, well, actually we can, but let's just assume that we can't say what the stars are.
Let me just repeat what he just said. We'll just assume we can't say what the stars are. Did you not understand what Neg said earlier? Did you not understand that, Alex?
What did he say?
He said we can't just assume things. We have to provide evidence for them.
Yes, and the only thing that I'm saying is that light in this model is traveling in linearly. There's no curves or anything to it.
So you're assuming that light travels in straight lines in this model?
Oh, are you now claiming bendy light? Because this is the only thing that can be proven.
No, it doesn't have to do with the light bending. It has to do with the assumption that the light is coming from a literal position, from a specific position.
Correct.
Well, I can basically counter this entire argument, this experiment that you proposed.
Nice one, Owen.
No, you can't.
Owen, are you saying that the stars are being projected from behind a couch?
Well, the main thing is stuff dips from perspective too, so these measurements after a while become unreliable. We're getting sniped. All right, well, see you in the next one, I guess. But can you still hear me?
Yes, I can hear you.
But I'm just saying that stuff is dipping from perspective too, so it's unreliable outside of perspective. That's the only thing.
Alexander, are you still here?
Yes, I am still here.
Ah, good.
So again, if we did the same thing,
Yeah, we got sniped. I know. It's okay. Only a couple of minutes of work. How you doing? Can you hear me?
Yeah, I can hear you. I'm hoping Jill comes straight back in and gets him before.
Share a link with him.
I don't even know who that was. There was a few people it could have been.
Yeah, it could have been a whole number of people. Oh well.
Alex, if you're out there, come back in. I'd like to ask you a couple of general questions about what you propose as your experiment.
Why is he proposing experiments when I'm asking for scientific proof? I don't get it. 2,500 years you guys have had to provide scientific proof or acquire scientific proof or establish scientific proof of Earth curvature. And all we seem to get is experiments going forward that we could do, that we could verify. Not that you've got any verified scientific
Nathan,
proof.
can I reply for a moment? I wanted to explain something right before I just got sniped, so there was well-timed sniping there. But what this guy was presenting is basically exactly exactly the same thing that Lewis was doing those months ago when he first brought up triangulation. And that is just assume that where these angles meet, depending on the model, would determine the exact position of that star, of that North Pole star. Well, that doesn't actually prove that it is physically there. And I wanted to tell you how you can actually find that out, and that is by going up into the atmosphere and then actually observe how that star is no longer there. So it's not, they don't have proof that it is physically in any specific position. All they have is the angular proof, the proof of the angle of those stars in relation to the position of the Earth. It doesn't prove the shape because you can assume that it's in a very close by distance, proving like the circle-centric disk flat Earth, or you can assume that it's very far away surrounding us on a globe. It doesn't really matter because they don't have any tangible proof of a physical, literal, specific distance or a size. They only have the angles, and that's the whole point. This is the same proof as Lewis brought forth those few months ago. It's exactly the same thing.
That is a valid point. The stars don't appear to be physical.
Completely agree.
It's an assumption that they are physical and that they are a fixed distance away, but when you go above a certain height, it appears to be the case that they magically disappear and disperse into the blackness of what they call space. Well, that's not consistent with the star that you're using for triangulation because it should be there on both elevations.
Yeah. Triangulation can only be accurate on provable physical objects on the Earth so that you can actually measure a exact size or distance, and then triangulation works. But it doesn't work for any heavenly body because you can't prove that they are physical or at a specific distance. Proof hasn't been found yet. At least, well, maybe NASA's did that, but yeah, it's not any proof that we can replicate. So
annoyingly, I'm gonna have to split. I've got to go and do something and be somewhere. How long's left on the show?
Let's have a little look, shall we? Half an hour.
Half an hour. All right. Well, if and when Alex does come back in, Nathan, would you do me a favor?
Sure.
Just for the sake of discussion, just agree in principle that his experiment proves what he claims it is. That it proves that we live on a little ball. But then ask him, then the other part of the experiment requires the same observations to be done on, quote, the South Pole. So we would need 3 observers or 2 observers at least looking south at the same time, doing the same experiments and observing the same set of stars. Most of us accept that seeing the stars in the north do what they appear to do, which is doing circumpolar star trails, like circles around the North Star. And most of us think or accept that there appears to be some evidence in the south of the same thing. However, the key point is 2 or 3 observers in the south, looking south at the same time, seeing the same stars. If that's there, that is what proves a ball. Doing it on the North Pole only proves a dome. You can't infer that it's sphere-shaped unless you do the second half of the experiment because there are 2 poles, apparently. Right? Did you get that, Nath?
I'm getting some bickering in chat that they're complaining, like, prove to me that they're intangible. And I tell them, prove to me that they are tangible. And they just say, no, you prove that it's intangible. Well,
yeah, he who asserts.
We're at a stalemate there, aren't we?
We're not using these stars.
You can't really use the stalemate to prove anything. That's the whole point. You can't use the heavenly bodies. You can't use the stars to prove the shape of the Earth. That's the whole point.
Yeah, he who asserts must prove. So don't tell me to prove they're not. You prove they are.
So you do have to prove that the rotation point in the south, A, exists, B is compatible or observable, comparable, and verifiable from at least 2 observation points south. And you have to show that you are looking at the same set of stars as opposed to a different rotation point that appears to be similar. The argument on the flat Earth is that there must be therefore 3 rotation points. Who knows? Maybe there is. You have to prove that they are the same set of stars in the south when looking south at the same time. So yeah, Alex can say that the north observation proves that it's spherical, but that only proves that it's spherical if you show the other half of the dome, the other half of the ball. Otherwise, the only conclusion you can logically come to with basing it on Polaris is that we are under a dome because we don't see the other half of the circle we're supposed to live on, or the other half of the ball.
Indeed. I'm just pleased that Neg was happy to assert that we need to prove things. We can't just assume them. So that's good. But I'll cite Neg every single time we have this assumption from now on.
But the thing is, there's flat earthers out there that have actually worked out the flat Earth star coordinations based on the same triangulation system that the globers are using, just simply assuming the stars are closer. Still no actual proof because they too cannot prove that the stars are actual physical objects. They just assume they are closer, and then it actually does work out on a flat Earth model. And we've seen this model even presented in CGI imagery, and it just works out. It's not proof, though.
Right, gents, I need to drop, so I shall catch you guys later. I'll be listening, but I can't preach my rhetoric, my nonsense, my lies. So have a great show, and I'll be back in a bit. I'll be listening, but I'll speak to you later.
Not a great deal of it left, to be perfectly honest, but
no.
Yes, I will post the link.
Tim's asking, are you going to post the link?
Yes, sorry, I forgot.
I think we must be too late though today, Nath, because obviously all the usual trolls are awake.
Right.
Tomorrow we must do it earlier so that they're all in bed.
But yeah, the link's now posted.
Good luck. Good luck on the back door, Arwin.
Thanks.
Bye.
See you later. So yes, as I say, we have approximately half an hour left on this live stream. If you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and a link in the info box below this video once it is rendered. Hello, Arev. Most importantly, though, if you'd like to join the debate, simply mute the page you are currently watching, then click the link in the info box to join the panel and express your views on the shape of the Earth. If you do join, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. With that, I'll transition back to the Hangout and say, as I say, we have approximately half an hour left on this live stream.
Sweet.
Good morning, all. I would just like to thank Anthony for admitting that he preaches lies and rhetoric.
He's just a flat Earth evangel. He's just
Hello.
So anyway, I was wondering, you guys said that there's no stars when you go above a certain altitude. Where's the evidence or proof of that?
Hello, everyone.
Hello, Matrix.
Just wondering, Arwigen, do you have any proof of the stars disappearing as you go up?
He's been kicked out already.
Oh, did he?
Literally in the time it took me to make a quick link. Hold on a second, I'll see if I can get him back.
Yeah, that would be good. And also, I'm wondering about this apparent horizon. I did leave you a message about it because really the definition of an apparent...
Hello, Owen. I think Tim has a question for you.
Yeah.
Hello.
Third time's the charm.
Yeah, Arwigen. So I was wondering.
Yeah, you can call me Arwin. You know how to pronounce my name. Stop being a dick.
Okay. So anyway, I was just wondering, what evidence or proof do you have that the stars disappear at a certain altitude?
Well, I've seen a lot of footage that demonstrates this effect, including NASA footage.
But NASA's fake, so you're using their evidence.
They could not really explain why in a proper way. All the footage,
so you can't explain
all
why.
the photographs that they have taken from the Earth at a far distance or even slightly outside of the atmosphere, as they call it, in orbit, they don't show any stars. Stars seem to only be visible
Arwen,
from the surface
but you
of
don't
the Earth
believe
or the
their
near surface
imagery
of the
is
Earth.
real.
And
So
that
how
is
could
pretty
you
much
use their evidence
a very
for
good
proof?
pointer.
Arwen, they
are not.
photoshopped the stars out. Arwen, they
And
photoshopped
NASA's
the
not the
stars out.
only people that take photographs. We also have independent people that send
Yeah,
camera up there.
balloon
So it's
footage.
not just one source.
Footage
They
also.
photoshopped the stars out. Everyone photoshops.
No, yeah, they
the stars
Photoshop
out.
them out. Sure, they do. Sure. Especially like
So
the
anyway,
very early
Arwen,
Apollo
they also
footage,
show
they Photoshop that out.
a
Right?
spherical Earth,
Because they had
Arwen.
Photoshop.
So you don't believe in NASA, so why are you going to believe that there's no stars in their imagery?
But
it's
it
all
isn't
fake.
just NASA.
No,
Why
but
did you just keep
it's
referring to
easier
NASA?
to trick a ball
That's my
footage
point, man.
somehow
I asked if you guys
than
had
it
any
is to
evidence.
actually.
So do you have any
They
videos
have
with
no
no
reason
stars?
in
Plenty
their
of videos on
cosmology. They
YouTube.
have no reason to
Moon
take
landings?
out the stars because they don't want those out. They want the stars to be, according to their model, to be out there. So they would have no reason to actually take them out. And it will take a lot more effort to take those out than to just leave them in if they were really there. And back then, during the Apollo times, they didn't have Photoshop.
But they're faking everything, so you're saying that they're
faking
real?
the shape
They're actually
of the
going
Earth.
up there?
That's what they're faking.
Hang on. Arwen,
If there were stars in those pictures,
that
they
case,
would
they should be
definitely
photoshopping the
leave
stars
them in because it would support their concept, their model. So
Arwen,
they would have
Arwen,
no discernible reason to take that out for any
Do you
reason.
understand, Arwen?
Doesn't make
Arwen,
any
do you know
sense.
do you understand what exposure is on a camera?
Arwen, they would be photoshopping the stars in, if what you're saying is to be true.
Well, they don't do that.
Did you even know that John the
didn't do that.
Morgile has a
They
video
do it
of a high
now
altitude
sometimes with
balloon
certain CGI
with the
models, but they
exposure?
didn't do that before. They didn't
Go ahead, Arwen.
Photoshop these stars in, especially during the Apollo times, because they couldn't do it back then. So
wait, what? They
that
did fake a whole.
would have obviously
landing, but they can't Photoshop
detracted
some
from
stars in.
the
Come on.
Yeah, go rewatch those moon
from the
landings.
quality of the entire footage that they would have to present and would make it all less believable, as they were trying to uphold the image that they were actually presenting proof. So
Dude,
You're
they
not
just
making any
they
sense,
took out
Arwen.
the stars.
Dude,
Even on the
can I
moon
say,
footage,
for
there's
millennia,
no
we've
stars
been looking up
either.
at
It's just
for a
like, oh,
millennia,
well,
we've been
why isn't
looking
it
up
there?
into
If you
Einstein
can see
seeing
the
stars,
Earth, but
right?
can't see any stars. Why would that be? Well, that's
Arwen?
because the stars are not tangible, physical suns out there that shine across the galaxy. They're only visible from within the Earth's atmosphere. That's what we can prove from all the footage gathered that's out there, all of it. And even balloon footage made by people here on Earth that are not related to NASA that wanted to look for their own proofs, they show that when you go high up enough, the stars disappear from view. I've seen many of these balloon footages do that.
So, do you understand what exposure is, Arwen?
What does that have to do with anything?
Exposure in a camera. Do you understand what that is, Arwen?
Yeah, I know what that is.
Okay. Do you understand that the brightly lit Earth would probably wash out very, very small pinpricks of light, as in the stars?
Oh yeah, does that explain why footage from the moon, of the sky
I just asked a question.
above the
Can
moon,
you just stick with that question,
where there
Arwen?
is no Earth in view, would not show any stars either? Is that a good explanation?
First of all, you don't believe in the moon landings, Arwen. Okay, you don't believe in satellites.
Sorry, I do actually want to know where Tim's going with this, and I'm not really following him. So I don't know, Tim. Can you explain what you're asking? Because I'm not really following where you're going with this.
I know what he's
questions,
explaining.
but I don't understand where you're
the
going with
contrast effect. If you look at something really bright and you then take a photo of that, then the contrast will take away the more shimmering, dim relating lights of the stars. That is a concept. Unfortunately, doesn't really apply like this. Doesn't apply at all. Like the
It
Earth
absolutely
is really
does
not
apply
that
because
bright.
there
Even.
are high altitude balloon footages. Even the Morgile has one on his channel where it goes 120,000 feet or whatever, and the exposure on the camera is different so that you can actually see the stars. So this is a meme that Globebusters Bob had created quite a while ago. Some kind of a red herring argument about, oh, well, the stars aren't seen from X amount of distance, but that's why
I
I
don't know
asked
the
for
X in that
evidence or
amount of
proof
distance.
of
I just know
this.
that
And then
they go
Arwen
away.
goes
And
about
hey,
NASA,
even if you
and
take
he doesn't
footage
believe in
from the
NASA.
moon of the
So
moon here on Earth, then yeah, it does seem very bright. But you know what? If the photo is wide enough and not really zoomed in on the moon, you can still see stars surrounding it. Not very close in close proximity to that apparent moon disk, but still a little bit further away, you will see stars. So it doesn't
So
really
I wanted
matter.
to get on to
Nathan.
what the apparent horizon is, when the definition of
let's talk about that.
horizon
Yes,
is
yes.
apparent line between the ground and the sky, basically. So what does the apparent line mean in flat Earth?
I don't really understand what you're asking. This is getting very
So the
weird.
definition of a horizon is the apparent line
Oh, we're going to go back
between
to proving the curve now again. So the apparent horizon and the real horizon, is that what you're now addressing? Because I can explain that
Okay,
pretty easily.
listen for just a moment, please. I'm saying that the definition of horizon is the apparent line, basically between that separates the sky from the ground. So, for instance, in where I live, I have giant mountains all around, basically my horizon. Okay, so it's where the mountains are meeting the sky. So I'm wondering what the apparent horizon is when the definition of horizon is the apparent line. So the apparent line, what does that mean? Sounds redundant to
Well,
me.
it has to do with optics. Like what you're referring to, the horizon as it is generally approached is purely based on visuals, is based on even art. Is how would you draw landscapes? How would you define certain aspects of what you are seeing? But when you to optics and things like refraction and all that, then you have to distinguish to the apparent horizon and the actual horizon. And the actual horizon, due to standard refraction, bending the light upwards at a certain distance, if the air conditions are right, and they usually are,
So Arwen,
then
this is
you will
what
have
is
the
called
real horizon
logic,
being
where you
slightly
just say a
above
bunch of
the
random
apparent
things
horizon,
and there's no
because
coherent
technically
argument at
you
all.
could see further, but refraction bends light up, causing the apparent horizon to seem a little bit closer. That's how that
There's
works.
absolutely no coherence in what you just said.
No,
That's
that's
kettle
perfectly
logic.
coherent. I explained it very well.
No,
I'm
sorry.
sorry
No,
you don't
please
understand.
go
I know
listen.
it's very
Please
hard.
go
It's very hard.
re-listen to what you just said to all of us in the chat. I mean, seriously, go re-listen to that and see what that actually means. If that makes sense to you after this call, then I don't know what to say, man. I really don't, because that was just a bunch of nonsense. Okay, I'm talking about the horizon, which is the apparent line
I'm so sorry you
between
don't
where
get it. I'm so
the
sorry.
ground
It's
and the
very
sky
hard. I
meet.
know.
Okay.
Yeah,
And
but
you went on
I'm
with
perfectly
optics and refract, just as you always
capable
do,
of
Arwen. You just go
explaining
on with
these
these
things by now.
optics
I
and you
know
just
what
say
I'm
it.
talking about. I know how it
No, you
works.
don't.
And I
No, you
haven't
don't, Arwen.
made any mistakes in my explanation. There's the apparent horizon, which is closer to you because of refraction,
Can I ask
causes
Arwen
that
something?
slant effect, and then the
Arwen, the
real horizon
horizon is
is
the
actually
apparent
slightly above that.
line
And in
that the
between,
ground
there is
and the
all
sky
kinds of
make.
miraging effects of objects that are obscured
Arwen, what is the
because of the
apparent
refraction zone.
line?
Hello. What is your
That's how
point?
it
Well,
works.
Hi
can you
Ken, how you
please explain
doing?
your point of this? What is your
Hold
point?
on 1 second, guys.
Hello.
Hi Ken, hold on. Hi Ken.
Hello, Ken.
Good to have you.
Howdy.
Good God.
Go ahead, Nathan.
Hello. Hello, how you doing?
G'day. So, Owen, what's optics? What do you mean by optics, Owen?
I've asked this question before.
Optics
Why does
are
it take
visuals. It's
2.7
about
seconds
the
for
workings
a
of
radio signal to
visuals.
bounce off the
That's what
moon?
that's about.
They don't believe that.
Repeat your question again, please, Ken.
Someone's got some noise happening.
Can you repeat your question, please, Ken?
No,
Can I just remind you guys, if you want to dispute refraction, you need to do a science degree.
Oh yeah, okay, yeah. Oh, sorry.
We need a
Sorry.
white
We can
coat.
only do science if we
love
went
it.
through the
We
proper
need a
channels
white
and got
coat.
vetted by a
What
bunch
is your
of scientific
explanation for it?
people.
No education whatsoever is required to adhere to the scientific method.
Wow,
It
I've got a
simply
lot
is
of
not
redundant
necessary.
speech
You
here.
do not need a science degree in order to examine refraction, Dawn. That's complete and utter nonsense.
Because otherwise you just end up with Arwen making stuff up, don't you? That's what happens.
Right. You don't
Yeah,
have
you know
to
what
have any
real scientists
qualifications
do?
whatsoever to adhere to the scientific method. Anybody can do it. You don't have to have a white coat. You don't have to have a degree. You don't have to have appealed to consensus opinion.
Trust me, to dispute refraction, how it works on the globe model.
I have
you
to
need a
trust
science
you in this,
degree.
do I, Dawn? See, I don't trust anybody other than myself.
Can you remember when
and my
Riley tried
own
to dispute it with
judgment.
an MIT paper and it turned out to be a secondary school in Japan, homework?
Yeah, apparently a very good
That
school.
was quite a special moment.
Yeah, apparently a really good school, China, but yeah.
All right, I'm sorry, I didn't get an answer. Why does it take 2.7 seconds to bounce a radio signal off the moon?
Why does it?
Because it's 238,000 miles away.
That's a lovely
And like
conclusion.
travels
And
at
that's the only
150,000
answer
miles
there
per
is?
second.
You're satisfied with that answer? You're
Just out of
100%
interest,
that's
Ken,
the case? Or
Ken,
that's
have you
just the
verified
bullshit?
that? Just out of interest, I'd like to know if Ken has verified that.
Exactly.
I know the
Have
speed
you
of light.
verified
And I know it takes 2.7 seconds.
have
It's
you
been
verified
by
that the
amateur
sun
astronomers
is-
and
Have
astronomers
you
alike.
verified it?
Have you
Hand
verified
operators.
that the
No, I have
moon
not.
is that distance?
Exactly. So you're just repeating information, exactly the same thing we're doing, but somehow it's more valid because it comes out of your mouth?
Yeah,
You
exactly.
don't actually assert anything that has any verifiable information.
Well, isn't that what we're doing here? We're having debates.
No, you're asserting bullshit.
Because my bullshit isn't valid and your bullshit is way more valid than mine, huh?
Do you have any experiments?
Do you?
I have lots of experiments by proxy.
Okay, I could say the same thing. Where's
Okay,
your proof?
please do
Wait.
give evidence of any of them.
What makes you think that the burden of proof is on me? I
Um,
know the Earth is flat. You're the one that's still figuring it out.
No, you don't know that.
I do.
You don't know
No,
that.
you don't.
Yeah,
How
I
do you
do
know
too.
that?
I know it's flat.
I know it's flat.
You don't,
do you know?
Nathan.
You
either.
have yet to figure it out. You're the ones that have to catch up. We've already realized that the Earth is flat. You
You
guys
have.
are the one that have to catch up. We don't
So
have
should-
to explain it to you. You're the ones that have to
This
understand.
guy is
why
really,
you
really
here?
ignorant. I've
You've
talked
had-
to him before.
You've had 3 or 4 years to prove the Earth is flat. You've got all this
You've
marvelous
had
technology.
hundreds of years to do the same, and we're still having discussions
you
about
didn't
it.
Let me finish.
2.5
Yeah,
thousand
how
years
about
of that.
a scientific
You've had the
body
technology.
of
Hang on.
hundreds of people working over centuries using
Boys.
the most advanced equipment, the biggest budget in the world, all of that to prove your globe. And you still can't bring any proof, can you? Still can't do it.
Google pictures of the stars. Time
You've
of
had
2 points of rotation in the sky.
I
It's
love it.
impossible.
Just Google it, man. Just
It's
accept what
almost
they
like
say.
the globers.
Look, man, it just says it on Google. Just accept it. If anybody wants to know the conclusion of this debate, just Google it. It's real simple. Just type into Google, is the Earth flat? And just simply accept the answer that you're given. It's really easy. Just Google it.
I'll do it for you. I'll bring it up now.
No, it's all right, Dawn. You're okay.
I think these guys are.
That was
Please don't show
directed at you. You accept it, Dawn. That's what you can do, my friend. You can accept what Google tells you. That's you, not me. I'm not going to just
You
Google
guys
it
actually got
and
stuff
accept the
that
answer.
works.
That's
Have you actually
ludicrous.
Have you actually got stuff that works?
No, and I did want to bring up as well. Arwen said that there is a accurate depiction of the stars on a flat Earth map. There absolutely isn't. Just wondering, Erwin, do you have a video, or what kind of proof do you have for that?
I've seen several videos, but yeah, they've been lost in the piles of videos. Could look back.
I think you go with the cosmic egg theory, don't you? Arwen, like a big cup above the flat Earth, something like that.
So we have star trails
that
that
is
go
one of
horizontally
yeah
at the- at
that
the,
is
pole,
the base
the South Pole?
concept for that. That is the base concept for the circle-centric flat Earth star model. It is it is just the flat Earth form of explaining as to the positions of the stars. I still do not agree to this, And yeah, despite not being very popular among flat earthers, I do not even absolutely
Arwen,
accept
you're
that
very
the Earth
convinced
is
by
perfectly
things that are
flat.
absolutely wrong
But
all
it
the
is
time. I'm
more
just
likely
wondering,
that it is perfectly flat than
you
that it's
really
a globe,
think
because
that
it's definitely
the
not a
stars
globe.
can work on a flat Earth?
It doesn't work out, but it seems to be as good as perfectly flat or very, very flat.
Do we have flat Earth videos
I don't know
showing
the
the
exact shape.
stars move
I have to
horizontally around the
concede
South Pole?
and actually be
They don't
honest about
understand. They
that. I
cannot
don't really know,
conceptualize what the
but I
stars
do
actually do in
definitely
real
know
life.
that it is not the globe. The assumed
Do you know what the stars are? What they
scientific
do?
size that
No,
you
I don't know what the
describe.
stars are or what they do. Hello, Lewis.
Well,
how
I
you
don't know
doing?
what they are, but we can observe
Hold on one
them.
second, guys.
We all
Hold on,
can observe
hold on,
them.
hold on,
Observation
hold on one
is
second. One
Okay,
second.
so
Some of them are
so
flat
you're
One sec, one
suggesting that
sec.
it's magic.
Hold on, Ken. Hi, Lewis.
You're
How you
suggesting
doing?
that it's magic, not me.
I
hear us,
hear you.
Lewis?
Some of the stars are planets. Well,
I just want to say hello
you
to
see in the
Lewis. Hold on
sky,
a second.
and you can see them.
Yeah, it's fine, Nathan. I already said hi. You don't have to waste time introducing people every time.
Ooh, very rude.
Jeez.
Good to have you here,
So
Lewis.
we have magic objects in the sky, and mine match with physics, not physics, but geometry. Like if I was on a globe, they spin at the South Pole, they spin at the North Pole, and you have magic ones that spin at the South Pole, but from multiple observation points.
They don't understand that it matches the latitude too. They have no conceptual idea of how it works on a sphere because they just disavow it. They hate
we
the
do.
sphere.
You
They think
explain it
it's a
so
lie.
many times. We've seen the explanation so many times. We've seen the explanation on TV. We've heard the explanation
You've never
in
had a
class,
debunk
on
for it. It
school,
works. The
every
celestial sphere
time. But now
works,
we're
dude.
just critically thinking about
Google
it
it.
and figuring out that it's a lot
It's a
of base
rectangle loop
assumptions there.
repeating.
A lot of base assumptions that you can't really scientifically prove. It's not
not
very
an
honest.
assumption, Arwen. You can go out yourself, change your latitude,
Yeah,
go to the southern
I know.
hemisphere.
We
You can
talked
go and
about
see
this
it
months
yourself,
ago.
buddy.
It's the exact
Okay?
same thing as the other guy right here in the Hangout today was doing. It's always the same thing.
All right,
Do
so
you remember
Arwen,
do you remember
have
when
you been?
Flat Earth was about
Arwen's-
observations?
Arwen's
I'm
flat
telling
Earth
you.
is a
Go
Arwen's
ahead.
flat Earth is a repeating rectangle or something. What do you call it, Arwen?
My flat Earth
Your flat Earth?
conceptual model, which I don't have any absolute proof for, but it's still
Oh, so
it's
your
still
bold ass
theoretical. Is rectangular looping? That's how I call it.
So
I mean,
when the celestial bodies move from the east to the west, they somehow hit a fourth dimension. Is that right? And they come back.
Now, my model is based on the
Who's the
standard
Muppet who was
assumption
saying
that
that,
all the heavenly bodies are purely holographic in nature and only are observable and appear on the edge of vision in relation to the observer. And the only actual changes that do relate to the Earth are the angular changes of the globe of the heavens over the Earth. And that is actually provable because that
How
is
do the
the
two
real
celestial points work on your
measurable thing that
rectangular
you can
looping
do
thing
with
then?
heavenly bodies.
Nathan,
Arwen,
spectacular
Arwen.
show as
Get the
always. Be
angle
sure to
difference.
plug yourself and
That
shit.
is what
I'll
you can
see
do
you
with
guys
it.
later.
That's
This
what
is
we can
retarded.
prove.
Thanks for being here, Lewis.
Excellent.
I'm so cool. My
Really
name's
kind
Lewis
of you to
Hackett.
drop by, Lewis.
Yeah,
Thank you.
good. But yeah,
Can
bye,
someone
dude.
answer?
Sorry, I just want to
answer?
take this moment to thank Lewis for being here. We're really grateful for you being here, Lewis. Thank you very much. Really appreciate it.
Yeah, what a contribution that was, Lewis. Very well.
So two celestial
Can you
points
talk to
are, and how do you
yourself?
explain that?
Can someone answer the question I have on my screen right now, please?
42.
Hey,
Is that
I'm
a
a
fake
B.
beyond the imaginary curve, I'm guessing?
Which screen are we looking at?
Mine.
Jared, the stars aren't
Yeah.
tangible, so.
Jared.
Can someone answer this?
Yeah,
Or
Jared, the
holograms
stars
or
aren't
whatever.
I can't
tangible.
see it. Oh. There you go.
What the object is made of is immaterial to this observation.
No, it isn't. We need to know what these things are to assume where they are. That's the point we are making, Jared. What you are doing is drawing conclusions from things that you have absolutely no idea what they are, and you assume where they are. That, in essence,
This
is
made
the
up
problem.
does not matter to this question.
Does it not?
We're not just talking about what they are. We're just
Well,
wondering
you
how.
can ask
if the
questions
Earth is
about
flat-
intangible objects all you like, but I don't really care about your questions about intangible objects.
Jared.
How can they be the same point on
need
the
measurable
celestial
proof of
dome if the
service,
Earth is flat?
Jared,
Because they're not at
gonna
the
tell
same
you-
point. They're just in a certain angle. That's all you really know. You can't prove that they are at the literal
Sky
distance
is
or
useless, but a
any of that.
that's good evidence. That is.
Nathan, do you think? Hold on one sec, Nathan. Do you think you could go to Discord, dude, like, and have your shows on Discord and just completely cut out all this sniping and crap?
Well, people would still be able to join and cause problems, though, wouldn't they?
Or Skype.
No, I mean you would be able to just mute them. They'd be done.
What's the point?
You can block someone from the server, and they would not be allowed back in at all.
Yeah.
If they
you should
are a
think about it,
continual
man.
problem.
That's fascinating.
It'd be a lot
Thanks
easier
for
for
the
you.
advice. I may do that one day.
Cool. Cool.
Oh, and what you were saying earlier, Arwigen? Triangulation.
Arwin!
Thank you,
Then
Alan.
why is the J?
Thank
in
you,
your
Alan.
He's Dutch.
I am.
name? Spell it correct.
We have to start calling you
Even that-
Jared.
I am spelling it correctly.
It's usually a girl's
But
name.
you
in
couldn't
Holland.
pronounce it in Dutch anyway, so I just used the
Not true.
anglified version of
Is it a universal
which is
name, Arwin?
Arwin.
Is it male and female?
No, it's male.
Okay.
No, it's not.
Yes, it is.
Why do you say that, Alan?
I'm just joking with Arwin.
Oh, fair enough.
Oh, that's fine.
That's better.
But even then, what you were saying earlier about triangulation requiring distance, that is incorrect. In triangulation, you are determining distance by comparing observations.
Determining
When you have
distance,
two-
are we? I love it.
Yeah. Wait,
So, have you
when
gone
you
and
have-
verified where it is then?
that's what triangulation does.
No.
You have
I'm asking
two-
you
No,
if
no,
you
no.
verified your triangulation. Have you gone and actually confirmed that's the case?
With
Long
stellar
pause.
objects, no, but with other
No,
objects.
you haven't. So you assume them, which is
Really?
exactly what we don't
So
do here. We don't assume
didn't
things
take
here.
Parallax readings and do
Yeah,
the
we
math
don't
along
assume
with
what they
the
are and where
astronomy
they are.
live.
We don't do that, Jared. That's not what we do
don't
here.
need to
More
know what an
extrapolations.
object
You
is.
don't
we
know.
don't
The
need to.
point is
You
you don't
don't
know.
need to.
Triangulation works perfectly on the Earth with actual objects that you can determine the size and the distance to, and then triangulation actually works. But when you apply them on the heavenly bodies, no, you have to drag in these assumptions every time, and it's not proof. It doesn't prove anything.
Yeah, I think I might just round out the show there. I think we're coming up on 57 minutes. Yes, we are. With that, I'll say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And also a massive thank you to all of the debating panel for making this debate possible. If you've not done so already, be sure to like, comment, share and subscribe. I've been Nathan Oakley and I will see you all in the next video.